In the last section of the course, we explored river and ocean systems in which water plays dominant roles. So let's shift gears for a while and consider what happens when water is scarce, rather than abundant. Droughts are simply periods when water supply is reduced. Now, although many people tend to think of droughts and heat as being naturally linked, hot really does not equal dry, even though people living in temperate latitudes often associate the two. Folks who live in tropical regions tend to have a much better understanding that hot areas can also be very humid, since they're more familiar with tropical rainforests. But folks who live in high latitude areas also realize that dryness can be associated with cold as well as heat. The dry valleys of Antarctica are among some of the driest regions on Earth. These valleys hardly ever experience any precipitation, simply because the air is too cold to hold much water vapor. So despite the presence of ice, there's no liquid water present. And droughts do not mean a complete absence of water or precipitation. They are just short-term periods of distinctly lower than normal precipitation or decreased water levels. Although this reservoir in England is usually filled to the level of the dirt and stone-covered areas, the water level in the photo falls much lower, because there has been less rainfall. Consequently, despite its green vegetation, this area is still experiencing a pronounced drought. So not all droughts result in parched and mud-cracked landscapes. But severe droughts can eliminate water reserves that populations and ecosystems rely on. So this almost completely empty reservoir is a troubling image. Because if ecosystems are used to having a relatively consistent pattern of water availability, any change in that availability can wreak havoc, which also includes human societies. The infamous Dust Bowl of the 1930s was caused by a natural drought which was compounded by human activities. It caused indescribable hardship to tens of thousands of people, forcing many of them to leave their homes, which resulted in one of the few times in United States history that refugee camps were common in our country. Droughts are short-term changes in water supply that can last months to decades. Changes that occur on longer time frames, like centuries, are instead considered to be climate change. In the United States, the average annual losses from droughts are over $6 billion, which is over twice as great as all the losses from floods or tornadoes. And although this pie chart suggests that hurricanes are far more damaging than droughts, this chart was based on events from 1980 to 2012, which includes Hurricane Katrina. And Hurricane Katrina accounts for nearly half the total damages from all the hurricanes that occurred during that time period. So if you take Hurricane Katrina out of the equation, then in terms of the United States, droughts are usually the most damaging natural disasters, again with an average of over $6 billion in damage. But that's only an average. In 1988 to 89, drought losses were over $60 billion, even measured in 1989 dollars. On a local level, Minnesota's crop loss accounted for $1.2 billion of that total. And it was not a coincidence that fires burned much of Yellowstone National Park that year, since the drought prepped the landscape, drying it out to increase the possibility of windswept wildfires. But crops and woodlands are not the only things that are lost during major droughts. Even in the United States, more people die from heat and drought than any other type of non-biological natural hazard. While elsewhere in the world, past droughts have killed millions. On average, roughly 40% of the United States is affected by drought every 7 years, so we live in a drought-prone area. North America's vulnerability to droughts is tied in part to its size, as the interior of large continents are far removed from moist ocean air. Eurasia is the largest continent, and in its center, Eurasia hosts large desert areas, along with the mummies of Tarim, burials preserved by the dryness of this continent's interior desert area. In a similar manner, although Africa's Sahara Desert is due as much to atmospheric circulation patterns as to the continent's size, Egypt is also a very arid area, famous for its mummies. But despite all the embalming skills of past Egyptian priests in tending to their royalty, the mummies of Egypt primarily owe their preservation to the region's arid climate, since even the bodies of Egypt's less wealthy citizens remain well preserved. But North America is the third largest continent. So geologically, the largest North American desert does not lie in the American Southwest, nor in Mexico, but is the Great Plains of the Central Continent, which were historically known as the Great American Desert, since water was so scarce that many people thought the area would never support large populations. And although it may not look like a classic desert now, When you fly over eastern Nebraska and Colorado, you can look down on fields of oddly shaped low hills. And the shape of those low hills should look familiar, because they have the same shape as desert sand dunes, which is how they formed. Many times in the recent past, much of the Great Plains area was even more arid than today, and the region was covered by fields of sand dunes, which now only have a thin cover of vegetation, making it easy for this golf course to come up with sand traps. In the United States, droughts are typically associated with changes in atmospheric wind patterns. Usually, air masses will flow west from the Atlantic, over the warm Gulf of Mexico, and then curve north to bring moisture to the Great Plains. But if the Atlantic Ocean warms, those moist air masses can be pushed further west to bring moisture to parts of Mexico rather than the Great Plains. So droughts hit the central region of North America. And temperature fluctuations naturally occur in the Atlantic Ocean. The AMO is a decades-long natural change in sea surface temperatures of the North Atlantic. For intervals of 65 to 70 years, the temperature of the North Atlantic surface water swings back and forth from slightly warmer to slightly cooler phases. Although the total change in temperature is less than 1 degree Celsius, it takes a lot of energy to warm the whole ocean surface up. So the warmer parts of the cycle translate to more hurricanes and a westward displacement of the jet stream, which in turn results in more droughts in the United States. Well, the newest warm phase of the cycle began in 1995, which is part of the reason why there's still uncertainty about the impact of present climate change on hurricane patterns, since it can be difficult to separate out natural factors from human-induced warming. But natural or human-induced, there's a strong possibility of increased desert plain dryness for the next few decades. But it isn't just the Central Plains that experience drought. Droughts in the south-central states are also tied to changes in atmospheric circulation patterns, this time to La Niña events, periods of increased upwelling off the western coast of South America, which end up displacing warm water to the west. But as the temperature of the ocean areas varies, those changes alter the temperature of the overlying air, which in turn results in changes in atmospheric circulation patterns, and hence changes in precipitation. Recently, folks in the United States have heard a lot about droughts in California. But we should realize that it isn't just California that is going dry. Droughts of the past few years covered much more than California. At times, they extended to over half of the lower 48 states, as well as reaching parts of Canada and much of Mexico. But California is justly in the news, simply because it holds some of the largest populations in the United States. So when California water reservoirs go from this to this, we need to pay attention. A lot of people and a lot of agriculture depend on this water, so its absence can have a ripple effect throughout our national economy. However, worldwide, many places are even more susceptible to droughts than the United States is, such as India. Although we often think of India as being an area more troubled by monsoon rains than droughts, the country is vulnerable to some very severe droughts. And India is particularly vulnerable, both because of its dense, high population, which greatly raises the potential risks from droughts, and because of its geography. India depends on monsoon rains for 85% of its total annual precipitation. But in turn, those monsoon rains depend on the time lag in temperature changes between land and sea areas. The temperature of air masses over water tends to remain relatively stable simply because of water's high heat capacity, which means that it takes a huge amount of energy to change the water's temperature. And conduction and convection can transfer heat in surface waters with deeper waters, so deeper water layers help to buffer and reduce any temperature changes in the surface water, which in turn keeps the temperature of overlying air masses more stable. In comparison, the land has a very low heat capacity, so land masses can warm up or cool down much more rapidly. And since the ground surface can only exchange heat with underlying soil and rock by conduction, which is much slower than convection, the underlying materials have little impact on temperature changes of the ground surface. So while summer warmth heats both the sea and land, air temperatures will rise more quickly over land areas, which create low-pressure systems. As the warm air over the land rises, surface winds will flow from the ocean towards the land, bringing ocean moisture to land areas. And when that moist air in turn warms and rises, as it rises, the moist air will cool to produce rains over the land. In cooler months, this airflow pattern is reversed. Since the land cools down more quickly than the water, a cool air, high-pressure downdraft system forms over the land. So winds flow from the land towards the ocean, and there's little to no precipitation over the land. Now overall, this monsoon system is relatively stable, but locally it can have a delicate balance, as a change in total rainfall as low as 10% can be significant. So India is caught in a delicate equilibrium. An increase in rainfall can result in widespread flooding and deaths, while a decrease in rainfall can lead to droughts and possibly even more deaths. Climate models suggest that present patterns of climate change could result in 5% to 10% changes in total rainfall, well within the range required to push India towards floods or droughts. And with its high population, the consequences could be severe. Drought has haunted India's history. The Bengal famine of 1770 left 10 million dead, while the 1782 and 1783 famines resulted in another 11 million lost. And a famine in 1791 to 1792 killed 1 million by itself. The Great Famine of 1876 to 78 and another in 1899 each caused roughly 5 million deaths. More recently, the Bengal famine of 1943 to 44, which occurred during World War II when Britain diverted much of India's crops to feed British armies, left 2 to 4 million dead. But then in the 1960s, Norman Borlaug, who originally started his career at the University of Minnesota, helped to lead the Green Revolution. Borlaug developed a short-stem, high-yield, disease-resistant variety of wheat, which greatly increased wheat yields. His work is estimated to have saved nearly 1 billion lives over the past few decades, which is a remarkable legacy for anyone. Now, some unexpected places are vulnerable to drought. A drought in Australia is not unexpected. But what about the Amazon rainforest? Could a tropical rainforest really be vulnerable to drought? Well, in 2005, the Amazon rainforest suffered its worst drought in 1,000 years. And studies suggest that the rainforest is extremely vulnerable to a drought, even one as short as 3 years, which could cause a collapse of the entire forest ecology. But how could a rainforest be vulnerable to drought? Well, the catch is that most of the moisture in this rainforest comes from plants. The rain is recycled moisture from plant respiration, rather than from ocean evaporation. So if deforestation and drought occur, they could push the rainforest ecosystem to a tipping point, into irreversible decline, which could have catastrophic consequences for world climate, since tropical rainforests take in immense amounts of atmospheric carbon dioxide, as well as having tragic consequences for global biodiversity. Yet an image like this, which mixes camels with recently abandoned fishing vessels, suggests that there might be more factors in play than just natural climate change. So in the next segment, we'll explore the origin of human-induced droughts.